Okay, yeah. February, March 2022, paper 1, variant 2. Question 1. Yeah. Student investigates a pendulum, measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. What's the average period of the pendulum? How can I find the average period of the pendulum يا شباب؟ يلا بسرعة. Average. What should I do? How can I calculate the average? Average period, what do I do? Average anything بقى مش average period بس. How can I find the average of anything? We just add them up. صح? So 17.6 plus 19.8 plus 17.6 plus 18.6. صح? Divided by, when you find the average, you add them and then divide them by their number. Okay. Can someone calculate this? يلا هيطلع كام؟ Um, hmm, يلا can you calculate it quickly? Okay, this should be if you add them and okay, I know the answer, I know the final answer. Okay, this would be 18.4. This would be 18.4. Is 18.4 the final answer? No, it's not the final answer. Why? Because this is the time, okay, time for what? For 20 oscillations. And the period is not the time for 20 oscillations. Actually, the period is the time for only one oscillation. Type. How can I find the period of only one oscillation? Very simply, all I need to do is divide by 20. صح? 18.4 divided by 20 would be طبعا 0.92. 0.92. Again, now we have the time for what? For 20 oscillations, not the period of each oscillation. We have the time for 20 oscillations. To find the period of one oscillation, we just need to divide by, we need to divide by 20. Okay, that's quite simple. Question 2. Yeah, question 2. Speed time graph. Which statement describes the motion of the object? يلا. The motion of the object. This is a speed time graph. صح? What's happening? What's increasing? What is increasing? Can I say that the acceleration is increasing? No, you cannot say that the acceleration is increasing. The speed, yes, the speed is increasing. The speed of the object is increasing with a constant. Why is it a constant acceleration? Why is this a constant acceleration? Constant acceleration, since we have a constant constant slope. We have a constant gradient. Constant slope or constant gradient. For constant slope or constant gradient يبقى we have a constant acceleration. خلاص؟ طيب. A tennis ball falls from the upstairs window of a house. Okay, falls from the upstairs window of a house. What can be said about the acceleration of the ball if the air resistance is ignored? The acceleration when the ball falls, what's the acceleration? What is the acceleration of free fall? We know that the acceleration of free fall is what? It's a constant number. What is it? 9.8 meters per second squared on Earth. So the acceleration of free fall on Earth is what? Is 9.8 meters per second. So if you have a falling object, a free falling object, the acceleration would be constant. It depends on the density. No. It depends on the mass. No. It increases. No. It stays the same. Yes, thank you. Okay, it definitely stays the same. 9.8 meters per second squared, as long as you can ignore the air resistance. Okay, yep. This is an interesting question. The mass of the full bottle, okay, the mass of the full bottle of cooking oil is 1.3 kilograms. This is the mass of what? This is the mass of the bottle, bottle plus what? Plus the oil. This is the mass of the bottle plus the oil. When exactly half of the oil has been removed, the remaining mass is 0.9 kilograms. What is the mass of the empty bottle? How can I find the mass of the empty bottle? Now we have removed half of the oil. We have removed half of the oil. how can I find the mass of the remaining oil? Oh, how can I find the mass of the empty bottle? Initially, it was 1.3. Finally, it became 0.9. So the difference between them, the difference between these two masses, these two readings is 1.3 minus 0.9, which is 0.4 kilograms. What's 0.4 kilograms? Huh? What is 0.4 kilograms? This is half, what's 0.4? Half of the oil. 0.4 kilograms is half of the oil. Now I need the empty bottle. I need to remove the remaining half. I need to remove the remaining half. So the half of the oil, which is 0.4 kilograms. What about the remaining oil? Okay. What about the mass of the remaining oil? The mass of the remaining oil would also be 0.4 kilograms. The mass of the remaining oil would also be 0.4 kilograms. So to find the mass of the empty bottle, you need to remove the remaining oil. You need to remove the 0.4 kilograms. So basically all we do is 0.9 minus 0.4, which would be 0.5 kilograms. The empty bottle without the oil at all, it has a weight, it has a mass. The mass of this empty bottle, how can I find it? By removing all of the oil. If you removed half of the oil, if you removed only half of the oil, and the mass which has been removed was 0.4 kilograms. So the remaining mass of the oil, again, I'm talking about the remaining mass of the oil, would also be 0.4 kilograms. If you remove the remaining 0.4 kilograms, you'd have 0.5 kilograms, which is the mass of the empty bottle. Okay? Mass of the empty bottle. I hope it's clear by now. Yeah. Okay. Question 5. How can I find the density? How can I find the density of the rock? Yeah, it's quite easy. Quite easy. Quantity one, we know that the mass is the density is the mass over volume. So quantity one, the final mass or the increase in mass. Is it the final mass or the increase in mass? No, it's the increase in mass. Yes. M2 minus M1. We find the difference in the mass. So it's the increase in the mass. But quantity two, the volume. How can I find the volume? Is it the increase in liquid or is it the increase in depth? I don't care about the depth. I care about the volume. صح? I care about the volume. So it has to be A. Again, density equals mass over volume. Mass of what? Mass of the rock. Is the mass of the rock 264? Huh? No, it's not 264. What's the mass of the rock in this question? It would be 64. Why would it be 64? Because you subtracted 264 minus 200, which would be 64 grams. So this is the mass of the rock, which is the increase in the mass. It initially was 200 grams. It increased to 264. So it increased by 64 grams. Okay, the quantity, you need two quantities to measure the density. Density equals mass over volume. Mass is the first quantity, okay, and volume is the second quantity. You need both these quantities to find the density of any object. So you need the mass, you need the volume. Density equals mass over volume. You find the increase in the mass and you find the increase in the liquid. Okay, quantity is a number such as magnitude, for example. You could say magnitude of the mass, the magnitude of the volume, or whatever. Yeah. This is an easy graph as well. We have a spring, we have some loads. Which graph shows the result of plotting the extension against the load? The extension and the load. Yes, the extension and the load. It cannot be C. Why can't it be C? Okay, C would have been right if this was the length and the load. Okay, if it was the length and the load, it would have been right. But the extension and the load have to be directly proportional. Why? Why do they have to be directly proportional? Because initially, was the spring extended? No, it wasn't extended. Initially, the spring had an extension of 0. It had its original length, so it was not extended. So initially, the extension was 0 and the load was 0. When you start applying a load, when you start adding the loads to the spring, what would happen? The extension of the spring would start to increase directly proportionally to the load. So it has to be D, direct proportion. Directly proportion. Huh. Any questions? Which are examples of friction? Which are examples of friction? Quite interesting. Which of these are examples of friction? Hmm, Yes. Is one only an example is tension? Is the force in the spring an example of friction? No. Air resistance, is it an example of friction? Yes, it is an example of friction. It wants to slow down the object. Is weight an example of friction? No, it's not an example. The only correct answer would be C. Two only. Okay. Hmm, حلو. I actually love this question. Which equation gives the moment? Which equation gives the moment? How can I find the moment? Moment equals force times perpendicular distance. صح? Perpendicular distance. طيب, force, we have the force. Definitely, we will cancel out C and D. It's quite easy. Uh, the perpendicular distance, is it Y or is it X? Force and X are perpendicular. Yes. F and X are 90 degrees. Yes. Perpendicular. F and Y are not 90 degrees. This is not a 90 degrees angle. I don't know what is this angle, but this is definitely not 90 degrees. So the only perpendicular distance would be X. Okay. F times X. Yeah. A child pushes a car, okay, along a horizontal surface and then releases it as the car slows down. What is the main energy transfer as it slows down? As the car slows down, what's the main energy transfer? يلا. What's the main energy transfer while it was slowing down? Chemical to thermal, chemical to kinetic, kinetic to gravitation, kinetic to thermal. Hmm. As it's slowing down, we had the car initially moving, and then it starts to slow down. Initially, it had chemical, you can't say definitely it didn't have chemical. It did have kinetic because it was moving. Okay, the kinetic, would it be transferred to gravitational potential energy? Well, this would have been correct if the car was flying. If you had a rocket, for example, if you were throwing the car upwards. صح. But you pushed the car on a horizontal surface. Eventually, the car will stop. Why? Because the kinetic energy is transferred into thermal energy, into heat energy, due to the friction between tires and the ground. Okay? Yeah, energy resources are used to produce electricity. Which resource is non-renewable? Uh, Non-renewable energy resource. Quite easy. Uh, Hydroelectric is renewable, waves are renewable, wind is renewable. Definitely the nuclear fission. Nuclear fission. Okay. Yeah. We have some appliances. Which appliance transfers the most energy per second? Transfers the most energy per second. 1, 150, 800, 3. Which of these transfers the most energy per second? Huh? Okay. We have some nice answers. Yes, definitely, يا شباب. It is D. Why is it D? Because 3 kilowatts means 3,000. 3,000 watts. 1 kilowatt is 1,000 watts. So the most energy per second is the power. Power equals energy divided by time. Energy per unit second per unit time. يلا. An object is at rest on a horizontal surface. Which equation is used to calculate the pressure? Quite easy. What's the pressure? Is it the mass? Pressure equals weight over area, mass times area, weight times area. We know that the pressure equals what? Force over area. C and D are wrong. A, لا, not mass. It is the weight. صح. Can it be the mass divided by the area? Huh? Which equation is used to calculate the pressure? Pressure equals force over area, not mass over area, شباب, okay? Not mass. We cannot divide the mass divided by the area. Weight over area. 13 is cancelled, okay? 13 is cancelled. Okay. Hmm. Yeah. 14. Which properties does a liquid have? Hmm. Easy. Which properties does a liquid have? Does it have a definite shape? Can it be compressed easily? Hmm. Yeah, this is easy. Huh. Does liquid have a definite shape? We know that it doesn't have a definite shape. Hmm. Can we compress liquids? Can we compress liquids? No, we cannot compress liquids. So it has to be D. Uh, Liquids and solids are considered to be incompressible. We cannot compress liquids or solids. We can only compress gases. Hmm. Yeah, 15. Again, quite easy. Brownian motion. Which of these diagrams is the Brownian motion? Okay. Can it be A? Hmm. Can it be A? No. Why can't it be A? It's a zigzag motion. It has to be random. Okay. Zigzag. This is not a random motion. So A is wrong. Can it be B? This is not a zigzag motion. This is a pattern. Again, this is wrong. Can it be C? Yes, it is. C. Random zigzag motion. D is also somewhat a pattern. It's also somewhat moving in a pattern. So it is wrong. Yes. What's the name given to the change of volume of gas when it is heated at a constant pressure? When you heat the gas at a constant pressure, what happens to this gas? When you heat this gas at a constant pressure, what happens? Any ideas? Okay. Hmm. Can we call it thermal conduction? No, it's not thermal conduction. Thermal conduction is wrong. Okay. When you heat a gas, what happens when you heat any matter? When you heat literally any matter, what happens to it? Thermal capacity? No, it's not thermal. Because it was removed. Thermal capacity was removed from the service. So you're not required to know what is thermal capacity. Thermal energy, when you heat it, the change in volume of the gas is called thermal energy. No, it's not called thermal energy. It's called thermal expansion. Yes, it's called thermal expansion because it expands. Okay, the volume increases. Yes, bravo. Okay, all of you got it right. Okay, thermal expansion. The volume increases. Yep. Next question. حلو. Some ice melts. So, slowly heated it, then he needs to know what's happening in this region, in section X. He wants to know what's happening in section X. Yalla. What's happening to the ice? Does the ice gain energy or does it not gain energy? Hmm. I think the ice would gain energy. So يعني that's just a guess. The ice would gain some energy. So C and D are wrong. Huh. Okay, it does gain energy. What about the temperature of ice? What about the temperature of melting ice? Okay, is the temperature increasing in this? Again, I'm talking about this section only. Yes, it does stay the same. Yes, it does stay the same. So in this section, what happens to the temperature? It stays the same. It has to be B. Melting ice, boiling water, they all have a constant temperature. While melting, it's constant. While boiling, it's also constant. حلو. The melting point of a substance is negative 78 degrees Celsius. The boiling point is 23 degrees Celsius. If I put this substance, okay, in a freezer, for example, or in an environment with a temperature of 0 degrees Celsius, what would happen to this substance? And if the temperature increases to 100 degrees, what would happen to this substance? If it was 0 degrees, if it was 0 degrees, what would have happened? Yes, definitely. Yes, thank you. At 0 degrees, it would be a liquid. 0 degrees, it would be a liquid. Why? Because it's above the melting point. 0 degrees is above the melting point. So it will be a liquid. At 100 degrees, which is above the boiling point, it's a gas. So it would be D. Any questions? Hmm. Yep. A student sets up an experiment. The rods have the same thickness. Which conditions should be satisfied in order to make this a valid test? Huh? How can this test be valid? How can this test be valid, يا شباب? Okay. How can this test be valid? If I need to repeat this test, for example, I have four rods, and all of the rods have some wax, which is attached to a nail. Each rod has some wax, and this wax is attached to a nail. They all have the same thickness and so on. Which conditions should be satisfied? Hmm. Okay, let's check out the conditions. Do I need the same size of the nails? I guess I do. I do need the same size of the nails. Do I need the same length of the rods? Definitely. Yes, I do need the same. It's quite obvious. So I do need the same size of the nails, and I do need the same length of the rods. What about the hot water? Should the hot water be kept constant? Kept at a constant temperature or not? No. No, why? Yeah, mister, it should be kept at a constant temperature. No, it actually shouldn't. Or it doesn't matter. Okay, it actually does not matter if the water is at a constant temperature or not. Why? Because all of the rods would receive the same energy from the hot water. Okay, if the hot water was at 90 degrees, they would all receive, for example, a lot of energy. If the water was only at 50 degrees, they would receive the same, they would receive energy, which is a bit less. Okay, it would be a bit less, but again, all of the rods would receive the same energy. They would receive the same amount of energy. Okay, it would be divided in the same. So it doesn't matter whether the temperature is the same or not. Okay, كده the best thermal conductor, okay, the rod with the best thermal conductivity, okay, the nail would fall the first. For example, if this was, let's say, if this was a copper, okay, okay, so definitely this one would, okay, the nail would fall the first in any condition, whether the temperature was 90, was 70, was 50, whatever temperature, the copper rod would, okay, the nail attached to it would fall the first in any condition. Okay, so it has to be C. I know this question, most of you would choose A. Okay, most of you would choose A, but sadly, A would have been wrong. Why? Because you're not. Okay, for this question, you do not need a temperature to be constant. Okay. Okay, yeah. Question 20. Two similar metal containers P and Q contain water at 90 degrees. Both containers are the same size and they are both sealed. The water in container P cools. Cools more quickly than Q. P cools more quickly than Q. Which of these answers could be correct? Which of these answers could be correct? Huh. Why does P cool more quickly? Hmm. P contains more water than Q. P contains more water. No, doesn't have to do with the rate of cooling. Hmm. P has a shinier surface than Q. P cools more quickly. Cools more quickly. So if it had a shinier surface, if it had a shinier surface, this means it would have cooled more slowly. This means that it would have cooled more slowly if it had a shinier surface. Why? Because shiny surface, okay, shiny surfaces because shiny surfaces are the worst emitters of infrared radiation. This means that the water would have been hot for a longer time. Okay, so B is wrong. It's actually C. Why? Because if you paint P a darker color, this means what? This means that it would lose energy at a faster rate. It would be a better thermal emitter or a better infrared emitter. Okay, it's the best emitter of infrared radiation. Okay. Hmm. Any questions? Hmm. Okay. This is an easy graph. It's a really easy graph. What happens to the amplitude and what happens to the wavelength? Quite easy. The amplitude and the wavelength. Initially, this was the amplitude. Ah, okay. Initially, this was the amplitude. And then, as we move on, what happens to the amplitude? The amplitude keeps on decreasing. The amplitude keeps on decreasing. So the amplitude decreases. What happens to the wavelength? Uh, Initially, it had a short wavelength, and then the wavelength kept on increasing. Yes. So the only right answer would be yes, A. Thank you. Yes, it would be A. The amplitude decreases and the wavelength increases. Okay. You have a question here? The white would reflect the radiation. The white is the worst emitter of infrared radiation. For question 20, the white is the worst emitter of infrared radiation. Initially, initially it was hot. Initially, it was hot. Okay, so if it cools more quickly, that means that it had a black surface, a darker surface. Okay, it had a black or darker surface. This because the black or the darker surfaces give off radiation at a higher rate. They are the better emitters. Okay, you cannot say it's the best reflector. You cannot. Why? I don't care about the reflection in this question. You do not care about the reflection in this question. Okay. Um, Frequency. Okay, question 21. You don't care about the frequency in this question. Okay, you do not care about the frequency. Um, if okay, nice question. If, for example, he said that it had the constant speed. And you know that the speed equals what? Frequency times wavelength. You know that the speed equals what? Frequency times the wavelength. For this case, if the wavelength increases, what happens to the frequency? The frequency decreases. If he told you that the speed was the same, okay, if he told you that the speed was the same and the wavelength increases, what would have happened to the frequency? The frequency would have decreased. Okay? Okay. Hell, question 22. Tank contains water. Ripples are produced on the surface. Refraction is observed. What causes the ripples to refract? What causes the ripples to refract? Yell, can someone answer? Why do the ripples refract in the water? Why do the ripples refract in the water? Cold water is replaced by warm water. The ripples change speed as they move from deep to shallow. Okay. The ripples hit the walls of the tank. This would reflect. Huh? If they hit the walls of this would reflect, not refract. Huh? The ripples pass through narrow gap. Huh? No, this would diffract. They pass through narrow gap. This would diffract, and this would reflect. Okay, this is wrong. Cold to hot doesn't matter. Definitely, it is B. Yes. Hmm. Which is the angle of incidence? I guess this is the easiest question. I hope all of the questions are like this one. Okay, which of these is the angle of incidence? Definitely, it is B. Definitely. Okay, it has to be the angle between the incident ray and the normal. 24. 24. Which diagrams are correct? Which diagrams are correct? Yep. Okay. Which of these diagrams are correct? Can someone tell me? Okay. Hmm. Is one correct? Does the ray pass through the center and continue in a straight line? Yes, it does pass through the center and continue in a straight line. Two. Hmm. A parallel ray as it reaches the center or as it reaches the lens, it refracts. Yes, it refracts and move downward. It does refract and it does move downwards. But is this correct? Is this diagram correct? Actually, it's not. Why? Why is it wrong? Because it has to move through the focal point. It has to move through the principal focus. Okay, this line has to go through the principal focus. So that's why two is wrong. Three is right. Why? Because initially it was moving through the principal focus and then it moves in a parallel manner. Yes, so it is C. One and three. Okay, it has to be C. Hmm. Which row is correct? Yeah. Which row is correct? Frequency and uses of infrared rays. When I need to compare the frequency of the infrared waves to the frequency of the microwaves, how can I compare their frequencies? How can I compare their frequencies? Infrared and microwaves. Infrared and microwaves. Hmm. Rami looks great. Infrared and microwaves. Hmm. Frequency, is it greater or is it lower? Frequency, as you're moving this way. What happens to the frequency? The frequency increases. صح? So you're moving to the right. What happens to the frequency? The frequency increases. So as the frequency increases, so the infrared is greater than the microwaves. What about the use of infrared waves? How do we use the infrared waves? Radiant heater or a satellite television? No, we do not use them in satellite televisions. We use them in radiant heaters. That's why we say, this object was heated by infrared radiation. The sun heats up the Earth by infrared using the infrared radiation. Hmm. Yeah. Question 26. Student investigates the sound waves from a loudspeaker. The frequency of sound is 25,000 hertz. The student has a normal hearing, okay, but she cannot hear the sound. Okay, she cannot hear this sound. What should she do if she wants to hear the sound from the loudspeaker? Huh. What should she do? Should she decrease the amplitude or the frequency? Will increase the amplitude or the frequency? Huh. What should she do? Hmm. Any ideas? Okay. Okay. Hmm. Good. Definitely, yes, definitely she should decrease the frequency. Why? Because 25,000 hertz is above the normal human hearing range. Okay. It needs to be less than 20,000 hertz. Needs to be less than 20,000 hertz. So she definitely needs to decrease the frequency. Yeah. 27, two isolated metal spheres are both negatively charged. Okay. Which diagram shows the charge distribution? What happens to the charge? Okay. If you have some negative charges, what happens to these negative charges on the spheres? Um, to be very honest, this question is kind of cancelled. Okay, kind of cancelled. It's not 100% cancelled. Why? Because you actually should know the repulsion and attraction. So are they attracted as an A? No, they cannot be attracted, nor B, nor C. What happens? They are, okay, they are repelled. They are repelled. The negative charges want to repel. They want to move in opposite directions. Okay. Hmm. Yeah. Next question. When a plastic comb is placed next to a small piece of aluminum foil, okay, the foil is repelled. It is now repelled. Why is this? Why is it repelled? Hmm. Why is the foil repelled by the comb? Hmm. It's charged and uncharged. They're both uncharged. They both have the same sign. Yes, they do both have the same sign. Yes, thank you. We have a resistance wire. Which wire made of the same metal has a smaller resistance? Yalla, we need to decrease the resistance. How can I decrease the resistance? Same length, larger diameter. Okay, this sounds okay. Same length, smaller. No, we need to decrease the diameter. Okay, When you decrease the diameter, what happens to the resistance? The resistance increases. So this would be wrong. Huh. Greater length, wrong. Greater length, wrong. So same length and a larger diameter because you need to decrease the resistance. Which labeled component controls the brightness of X? Huh. Controls the brightness of X. Quite easy. Huh. A lot of you might say D. A lot of you might say, Wallahi, D is an LDR, so LDR it has to do with the brightness, but D has nothing to do with X. To control the brightness in X, you need to vary the resistance in the variable resistor, which is B. Yeah, question 31, which statement about the readings on the ammeter is not correct? Okay, which of these statements is wrong? Yeah, which of these statements is wrong? P has a greater reading than Q. Definitely, it's wrong. They both have the same reading. Okay, they both have the same reading. Okay, P and Q, they both have the same reading. Yeah. Um, an electrician sets up a potential divider circuit in a fridge. Okay, so that when the fridge door is open and light from the room enters the fridge, a warning light turns on. Which component does the electrician need for the potential divider in addition to a variable resistor? We need some component, okay? What does this component do? Okay, what's the purpose of this circuit? Okay, when you open up the fridge, when the door is open and light from the room enters the fridge, another light turns on. Huh. Which of these components should we add to the circuit? Okay. Hmm. Definitely. It has to be, huh? Definitely has to be A. Yes. The only component that depends on the light. Okay. Light coming from the room. When you have some light coming from the room, then you need a light dependent resistor. Hmm. Yeah, simple wiring diagram for an electric cooker is shown. Why? Uh, Why is there a wire connecting the metal case to the earth? Why do you have an earth wire? Again, why do you have an earth wire? What's the purpose of an earth wire? What is the purpose of an earth wire? Huh. It improves the efficiency? No. It prevents the metal case from becoming too hot? No, again. It reduces the risk. It does reduce the risk of an electric shock if the wire touches the metal case. Yes, if you have a metal case, then you need an earth wire. Why? To reduce the risk of an electric shock. To reduce the risk of an electric shock. This is the purpose of an earth wire. Okay? Okay, good. Question 34. Three statements about AC and DC circuits currents are given. A DC current is one direction. AC current repeatedly changes. DC is abbreviation for direct, and AC is abbreviation for amplitude current. AC is one direction, and DC repeatedly changes. Which of these would be correct? طيب. Okay. طيب. It's three only. An AC current is one direction. No, that's wrong. This is wrong. AC is only AC repeatedly changes. So this is wrong. A DC is one direction. Yes. AC repeatedly change. Okay, so A is wrong. One is right. DC is the abbreviation for direct. Yes, okay. And AC is the abbreviation for amplitude. No, it's not amplitude current. It's alternating current. So it's only one. One only. Yep. Question 34. Question 34. Two magnets are placed near a current carrying wire. Current carrying coil. The diagram in this experiment arrangement and the current direction. Okay. Which statement is correct? Which of these statements is correct? Hmm. Okay. Which of these statements is correct? Okay. Hello. Actually, this is a really hard question. This is a really hard question. Why? because you do not have any other questions in your syllabus or in any other past papers, paper one or paper three or whatever, that are related to this same exact question. Okay, in this question, you need to okay, you need to find the magnetic field of the coil. In this question, you need to find the magnetic field of the coil. And to find the magnetic field of this coil, it would be quite hard. But for this coil, the magnetic field would be north and south. For this coil, the magnetic field would be north and south. How do you find it? It's using something called the right-hand rule grip. Okay, right-hand rule grip. Right-hand rule grip in this case would be facing the right-hand side. Yes, it would be facing to the right. If you have your right-hand rule gripped, okay, if you close your hand, you close your four fingers, you'd find your thumb facing to the right. If your thumb is facing to the right, so the north pole would be on the right and the south pole would be on the left. Both X and Y are repelled. Now, north would repel the north and south would repel the south. Okay, in this question, you should choose either A or B. Okay, in this question, you should choose either A or B. Why? Because it would be either south or north, or if someone didn't know, it could have been south and north. Okay, south and north would have meant that they would both attract. Okay, but for this case, it would be wrong. North and south in this way, it would be wrong. So either way, you need to know that C and D are cancelled. Either way, you need to know that C and D are cancelled. Why? Because they would either both attract or they would either both repel. This is a really hard question. Honestly, if you had this question in your exam, okay, if you have this same question in your exam, what should you do? You should leave it. Okay, what should you do? You should leave it and then come back to it later. Okay, this question, my honest opinion is to leave it and then come back to it later on. Do not try to solve this question in your exam. Why? Because it's really hard. Okay, it shouldn't be in your syllabus. It shouldn't be in your um and in your exams. This should be an extended question. Honestly, this should be an extended question due to the right hand rule grip. Okay, so if you do not know how to use the right hand rule grip for now, honestly, do not do not try to solve this question right now. Okay, as for this instant, if you do not know how to solve this question, just leave it and then come back to it later. Okay, I'll try to solve it later on, maybe uh sometime. Okay, but for now, I honestly do not care. I do not need you to spend too much time on this question. Please, okay? Please do not spend too much time on this question. Just leave it and then come back to it. Okay? Leave it and then we might come back to it later. Okay, let's just move on to question 36. Okay, it is a hard question. 35 was a hard question. 36 is 1,000 times more easier. Okay? Which arrangement could be used as a step-up transformer? A step-up transformer. Yell. How can I step up the voltage? How can I step up the voltage? Yell. Quite easy. Question 36. How can I step up the voltage? Yell. How can you step up the voltage? Yes. Definitely C and D are wrong. صح? C and D are definitely wrong. طيب, would it be A or B? You cannot use a DC input. You cannot use a DC. It has to be an AC input. Definitely has to be an AC input. Yep. Which diagram shows the structure of an atom containing a nucleus and two orbiting electrons? Yeah, quite easy. Which of these is the atom? Cannot be B. Cannot be D. Hmm. It cannot be A. It's only C طبعا. Definitely it's C. Hmm. Yep. 37C. Yep. 38, a nucleide has a symbol. Which statement about all the atoms of this nucleide is correct? Hmm. يلا, that's quite easy. Of this nuclei. It has to be, there are 6 protons in the nucleus. 6 protons in the nucleus. Yep. The least penetrating and the most ionizing. Which of these is the least penetrating and which of them is the most ionizing? Okay. The least penetrating is alpha. Yes, it is. The most ionizing is also alpha. Why is the most ion? Because it's positive 2. Okay, it has a positive charge of 2. The gamma has a charge of 0, so it's not the most ionizing. Actually, it's the least ionizing. So the least penetrating is alpha. The most ionizing is alpha. The least ionizing is gamma, and the most penetrating is gamma. Okay, this is the most, okay, penetrating and the least ionizing. Hmm. Yeah. Question 40. What is the half-life of the isotope? How can I find the half-life of the isotope? Hmm. Initially, it was what? Hmm. 38,000. So we need to divide 38,000 by 2, hmm, which is 19,000. صح? You don't have 19,000 in the table, but it's somewhere in the middle. It's somewhere here. So it's between what? More than 1, but less than 2 years. More than 1, but less than 2 years. Okay.